Good morning, students. It's 22nd of April, and I want you all to open your books, page number 504. This page is about the metals. What are metals? The chemical elements may have many properties that are different from element to element. The chemical properties of elements, they differ from each other. There are some properties, however, that are similar among elements. Scientists divide the elements into three main groups based on their similar properties. Now, what the scientists noticed, they noticed that some elements, they have the same properties, and they divided all the elements into three basic groups. Those groups are metals, non-metals, and metalloids. Now, of all the elements, about 75% are metals. Out of all the elements, 75% are metals, and they are on the left side of the periodic table. They are arranged at the left side of the periodic table. Metals share a common set of properties, means there are some common properties among all the metals. What are those? They are shiny. They are shiny when polished. They shine when they're polished. They conduct heat and electricity well. Good conductors means. And can be shaped without breaking. They can be shaped. They can be bent into other shapes. The more an element displays these properties, the more metallic it is. Means if they show more of these properties, it means they are more metallic. Some metals are more metallic than others. Now, if we talk about the metals, so some are more metallic, some are less metallic, right? A shiny surface is one way to identify a metal. Most metals are shiny, and many can be polished to be reflective. Now, some metals, they are very shiny, and others they can be polished to be shiny. We can polish them. Metal surfaces will typically reflect not only light but also heat as well. The metal surfaces, they will reflect the light also, and they will reflect the heat also. They will reflect the light also, and they will reflect the heat also. Most metals conduct heat very well because they are good conductors. Looking at the cookware in your kitchen, you will see that most is metal. If you look at your cookware in the kitchen, the cooking pan and the cooking dishes, they are mostly made of metal. Why? Because they conduct heat well. A metal cooking pan helps spread the heat evenly so that the food can cook. They conduct the heat in a good amount. They are good conductors. Metals are also good conductors of electricity, especially copper, gold, and silver. Now, they are good conductors of heat as well as electricity. They are good conductors of electricity also, especially copper, gold, and silver. Metals are easy to shape because they are malleable. We can easily shape them. What is malleability? Malleability is the ability to be bent, flattened, or hammered without breaking. Means we can bend them, we can flatten them, we can hammer them, but without breaking. They don't break. Gold is very malleable metal. Gold is very malleable. We can change its shape. A single gram of gold can be flattened into 1 square meter. Means we can flatten 1 gram of gold, and it can be flattened up to 1 square meter. This property is called malleability. Now on page number 505, we have the same topic. Metals are also ductile. Now what is ductile? Ductility is the ability to be pulled into wires without breaking. Ductility is the ability of the metal to be pulled into wires, and again without breaking. Okay, the ability to be pulled in wires. Copper is often drawn out into wires for conducting electricity in buildings and electrical equipment. Usually mostly we use copper in wires, and those wires, with the help of those wires, electricity is provided. Silver and platinum are also ductile. Silver and platinum, they are also ductile. Chromium is the hardest metal, and cesium is the softest metal. Chromium, hardest metal. Cesium, softest metal. You can compare the hardness of metals using Mohs hardness scale. There was one scientist, he made a scale that's called Mohs hardness scale. In that chart, or in that scale, he has categorized all the metals according to its hardness. Mercury is the only metal that is liquid at room temperature. This is the only metal. Mercury is the only metal in the liquid form at room temperature. The metals tend to react with other elements. The metals, they react with other elements. The metals' chemical properties vary quite a bit. Now, if we talk about all the metals, so their chemical properties, they vary from each other. They are not same for all. Some metals, such as gold, are very unreactive. Gold is a metal, but it is unreactive. Other metals, especially the metals in the first column of the periodic table, are very reactive. Now, some metals, especially those who are listed in the first column, they are very, very reactive. Okay. Now, what happens when they are left outside? When the metals left outside, many metals will corrode. What is corrode? Corrosion is when metals combine with non-metals from the environment. When metals, they react with non-metals that are in the atmosphere, that are in the air. When the metals react with those non-metals, this process is called corrosion. The metals corrode, or you can say the metal damages. It weakens. Like, for example, iron corrodes by rusting, which causes the corroded iron to flake away. When iron reacts with oxygen, rusting is rusting. Rust is made. It damages the iron. So we say that the iron is corroded. It will make the iron to flake away. It will be broken. The most reactive metals corrode the fastest. Now, the rate of corrosion, it depends on the rate of reactivity. The more the metal is reactive, the more it will corrode. The more the metal is reactive, the more it will corrode. Okay. Sodium and potassium, for instance, must be stored under oil to keep them rapidly combining with oxygen in the air. Sodium and potassium, they are very highly reactive. So if you place them anywhere, it must be stored under oil. It must be stored under oil so that it don't react with oxygen in the air. Now, on the right side of the page, you have the picture of the Statue of Liberty in America. The Statue of Liberty is not painted, but if you look at it, it's green color. Why? Its green color combines from corroded copper. It reacts with the non-metals in the air, and there's a green color on it. So this is also example of corrosion. Now on the next page, we have how do we use metals? Some periods of human development are named after metal that was most commonly used at that time. If you look at the past, some era of the human development, it is named after the metals. Some period, they are named after the metals. Why? Because during that period, some metal was introduced at that time. For example, the Iron Age. Iron Age marks the time when humans first introduced iron tools. When iron tools were introduced, people were using iron tools. That time is marked as the Iron Age. Metals in these times were used primarily as tools, but also for jewelry and even medicine. At that time, iron was used for tools, but for jewelry and for medicines also. Today, metals are still some of the most important metals in our lives. Think of all the places you see metals. Now, in our life, where do we see the metals? Buildings, bridges, utensils, and many more. In all these places, we use the metals. Some metals are used because they are strong and flexible. Some metals we use because why? Because they are very strong and they are flexible. They are flexible. Iron is a good example. Why? When combined with other metals, iron can become very strong and flexible. When we combine iron with some other metals, it become very strong and flexible also. Using this form of iron, skyscrapers can be built to be hundreds of feet tall. We use this type of iron mixed with other metals because it will be very strong and it will be flexible also. We use this iron to make skyscrapers that are hundreds of feet tall. While these metals support the weight of the building, they also allow the building to sway slightly in the wind. Now, because they are very strong, so they can support the weight of the building. This is the one thing. Second thing, they are very flexible also. So if they are flexible, they also allow the building to sway slightly in the wind. If there is very strong wind, they can sway and the building is safe. But if skyscrapers didn't bend, they would be blown over. If there is no flexibility in the skyscraper, so what will happen? It would be blown over. One of the most versatile metal we use is aluminum. Aluminum is often used in mirrors because it is inexpensive and can be polished to be reflective. It's aluminum we use mostly in mirrors. Why? Because it is inexpensive and it can be polished to be reflective. Aluminum foil wrapped around food will trap the heat inside by reflecting it. We use aluminum foil to wrap the food. Why? Because it will trap the heat. Our food can be warm over long time. Just like copper, aluminum can be used to conduct energy cheaply. Now, aluminum also, it is a good conductor, so we can use it to conduct energy also. Both metals are used in electrical wiring. Who? Copper and aluminum. They can be used in electrical wiring. They can be used in water heaters and they can be used in radiators. Why? Because they are good conductors. Aluminum is easily coated with a thin layer of oxygen. This helps prevent corrosion. Now, aluminum, it is easily coated with layer of oxygen. It is easily coated with oxygen. So what's the benefit? It will help prevent corrosion. There will be no corrosion. It will not be corroded. Its life will be long then. Okay, class. After this, move on to the next page. We have sometimes doctors place metals in patients' bodies during surgery. During surgery, sometimes surgeons, they have to insert some metals in the human body. For example, artificial teeth, hips, and even hearts can be made of certain metals. Even hearts also, they are made of certain metals. For example, doctors may put a metal pin inside a broken bone. If the bone is broken, sometimes they have to insert a metal pin in it. The metal pin supports the bone as it heals. Okay, to support the healing of the bone. Doctors may also use metal staples to hold large wounds closed. When the wound is very long, when the wound is very large, sometimes doctors, they use metal staples. So metals are also used in the human body. Now, when metal is used in surgery, doctors must be sure that metal will not react with elements in the body. Now, this is a very important thing, that if the doctor is using any metal inside our human body, so he must be very careful that it must not erode in the body. It must not react with other elements in the body. Gold and certain kinds of silver and titanium are all safe because they are unreactive in the human body. Now here they're saying gold, silver and titanium, they are very safe. Why? Because they are highly unreactive. They don't react. So doctors can use these metals inside the human body. Other metals are useful because of their reactivity. Now there are some other metals also. They are also good. Why? Because they are less reactive. Batteries batteries use the reactivity of metals to release electrons and generate electricity. Now batteries, they can be the batteries use the reactivity of metals. Inside the batteries there are metals. Which metals to be placed inside the battery? The reactive metals, to support, to release the electrons and generate electricity. Among these include cadmium, nickel, zinc, mercury, lead, and lithium. They are all used in batteries. Okay, in the batteries we can use cadmium, nickel, zinc, mercury, lead, and lithium because of their reactivity. This is at the bottom of the page. There's a picture given. This is an X-ray. See, a metal is used over here. So that's all for today. Inshallah, we will continue on Thursday. Thank you.